there are some properties and the concept of modulus function. We'll look into each of the properties and the concept. We'll also test with some numbers so that it is very clear. So let's start with the first property. It says that if under root of x square or under root of x square equals to modulus of x, that means that a square root of any quantity is defined to be non-negative. So a square root of any quantity will always be non-negative. It means it will always be positive or non-negative. In the case of 0, it would be 0. So to be perfect, it is non-negative. Now let's take with an example. What is the value of square root of 36? It will always be equals to 6. And what would be the square root of minus 6 whole square? This is nothing but the same 36, and this will also equals to 6. Okay, so in both the cases we are writing 6 because we are taking the value as modulus of x. Okay, so in this case what we are doing is minus of 6 and modulus of minus 6. So a square root of any quantity will always be non-negative, and to make it non-negative we are using the value of, or we are using the function modulus function. Hope this is very clear. Please do remember this property because people get confused and we make a silly mistakes or get into the trap that a square root of any quantity will always be a positive value or a non-negative value. Now let's look into another concept. As I've explained that if x square equals to 36, then x can have, in this case x can have two values. X can equals to 6 or it can equals to minus 6. But in case of under root of x square, x will always have a positive value, or modulus value. We'll try to get the modulus value of the given function. Now again let's look into other property, which was the basic property of a modulus function. If modulus of x equals to x, it means that x equals to 0. So this was the basic property of the modulus function. Now the another property, if modulus of x equals to minus of x, this signifies that x is less than 0. It is just the reverse of what we have seen. We have seen that when x is less than 0, modulus of x equals to minus of x. So it is just that what we knew. It is just the reverse of what exactly we have seen, that if modulus of x equals to minus of x, then x is less than 0 or x is negative. Now let's look into another property. It is just the same. It is just the repetition. If modulus of x is greater than x, then x is greater than 0. Now the another property is minus of x into modulus of x. If it is greater than x, then x is less than 0. Let's see this with an example. So what is exactly the function? Minus of x into modulus of x is greater than x, then x would be less than 0. This is for sure. So you'll get many questions of inequalities to try and test and check which must be true, which can be false. So this is a particular function which comes in the question, and you must remember this, that minus of x into modulus of x is always greater than x. In that case x is always less than 0. So if you have this function, then you must remember that x is less than 0. Let's try and check it with a value. Let's try and check it with a positive value. Let's suppose when x equals to 5. In the case of x equals to 5, minus of x, that is minus 5, and modulus of x, which you'll get as 5, and is this greater than or equal to x or not? So we can see that minus 25 is greater than 5, which is false. So this condition is not being held. Now let's check into another case when x equals to minus 5, or when x equals to minus 5. In this case minus of x would be 5 and modulus of x would also be 5, and this is greater than minus of 5. So 25 is definitely greater than minus 5. So this condition or this equation will always hold true when x is less than 0. So this is one of the property that you must remember. Now let's look into another property. It is just the similar property, that minus of x into modulus of x is greater than 0, then x is less than 0. So minus of x into modulus of x is greater than 0, then we must know that x is less than 0. It is just the same corollary from the previous property. Okay, over here we have, in place of x we have kept 0. So it was less than x, or x was less than 0. Over here it is again the same, x is less than 0. Just the same or the other thing. Now the very other important property, or very simple and the obvious property, if modulus of x minus a is, or a is greater than 0, then x cannot be equals to a. What happened when x equals to a? When x equals to a minus a, this will equals to 0, and we have to make it greater than 0. So x cannot be equals to a. Now let's look into another properties that we have. Very important and interesting property. Again, it goes with the basic concept of the modulus function, that x upon modulus of x, if it equals to 0, then x is greater than 0. Why? Because if x is positive, this modulus function would give a positive value, that is x upon x. We are taking the case in when x is greater than 0, then modulus of x would be x, and this would equals to 1. So it is just the reverse of what we have learned. Similarly, there is another property. If x upon modulus of x is minus 1, then we are sure that x is less than 0. Now what happens? X upon modulus of x, and what happens when x is less than 0? Then we write modulus of x equals to, minus of x, and this equals to minus 1. So if you get this, you can talk, or you can say about the reverse thing, that x is less than 0. The so very obvious thing. So these things should be very clear, or these functions should be very clear, and you should directly get what exactly would be the nature of x, or where would x lie. Will x be greater than 0? Will x be less than 0? So you should be very clear if you get these functions. Now another important and the very obvious thing, that if modulus of a equals to modulus of b, there can be two cases. First, a equals to b, or a equals to minus of b. Let's check with an example. Modulus of 5 equals to modulus of 5. Both will give the value of 5, then a equals to b. Also in the case when modulus of minus 5 is also equals to 5, or modulus of 5. In this case, a equals to minus of b. So we need to be very careful when you are equating the modulus functions. Now let's look into some more properties of modulus function. Again, if modulus of x equals to a, then x equals to a, or x equals to minus a. Of course, when modulus of x equals to a, then x can be equals to a, or x would equals to minus a, because modulus function will always return a absolute value or the non-negative value. Now let's look into another property, that if modulus of x is greater than a, then x is greater than a, or x is less than minus of a. We can easily understand this concept by using number line. Let's suppose 0 is over here and a is over here, and it says that modulus of x is greater than a. What is modulus of x? It is the distance between the point x and a. So x must be in this region, a to infinity, in this region, a to infinity. Then only the modulus of x, or the distance between these points, at which point the x is, would be greater than this distance. Similarly, we can take this concept on the left hand side. If let's suppose this is a, or this would be minus of a, then when x is on this region, then this distance, or let's suppose x is in this region, or it is minus of x, then this distance would be greater than this distance. So the region for x is this region and this region. So if this is the region, then x is less than minus a, and if this is the region, this region is called as x is greater than a. So this is the whole concept, that if modulus of x is greater than a, then x would be greater than a and less than minus of a. Now let's look into another property, very similar. If modulus of x is less than a, again on the number line, this is the number line, we have 0 over here, a is over here, and modulus of x is nothing but the distance of point 0 to x, and if this is less than a, then x must be in this region over here to here. And similarly, on the left hand side of the number line, a can be pointed as minus a over here, and if this distance is less than a or this distance, then x must lie in this region. So this region, if x is in this region, then x is greater than minus a. If x is in this region, then x is less than a. So we can collectively write as x is less than a and greater than minus a. So this is the whole concept. Now let's look into further more properties. So that is all the properties that you need to be very clear of with the modulus function. We'll look into some good questions of data sufficiency and problem solving and further clarify the concept on it.